So you may be wondering, what is the atomic radius? Well, I'm glad you asked. The atomic radius is half of the distance between two combined nuclei because it is difficult to measure the radius of one individual atom. The atomic radius is usually measured in picometers or angstroms. There are two things you should notice in this diagram containing atoms A and B. Notice that they are chemically bound together. Secondly, there is a slight overlap of the electron orbitals between the two atoms. So just keep in mind that the atomic radius is not the actual true radius of the atom. It is the most stable way of measuring the radius. So even though there is a slight overlap between the orbitals, this is the preferred method for measuring the atomic radius. So what is the atomic radius trend as you make a vertical descent down the periodic table? This is also called going down a group, though I prefer not to say go down a group because students often get that phrase confused. So I'm going to stick with vertical descents. The atomic radius increases as you vertically descend the periodic table. Why does this happen? Simple, it's because there are more energy levels that make the atom larger in size. Because electrons tend to repel each other, the more electrons there are, the more likely they are to push each other away from the center of the atom. So let's practice this trend of the atomic radius on a vertical descent. Which of the two atoms has a larger atomic radius? Is it magnesium or is it strontium? I hope you chose strontium, but the question is why? Why is strontium larger in atomic radius than magnesium? Is it because strontium has more energy levels? Is it because strontium has fewer energy levels? Does strontium have more protons or does it have fewer protons? First, I hope you recognize that since we're talking about a vertical descent, this has nothing to do with protons. So it means that strontium either has more or fewer energy levels. And if we are to look on the periodic table and locate that magnesium and strontium are in the same group, but in different periods, strontium has more energy levels because it exists on a larger period. Magnesium is in period 3 while strontium is in period 5. Let's practice some more. Which of the two atoms has a smaller atomic radius? Is it going to be oxygen or selenium? In this case, I hope you chose oxygen. So then the question is, why is oxygen smaller than selenium? Is it because it has more energy levels? Fewer energy levels? Does oxygen have a lower nuclear charge or a higher nuclear charge? Because we are still talking about the atomic radius on a vertical descent, that means these two elements must be in the same group. Therefore, it has nothing to do with the nuclear charge. So either oxygen has more energy levels or fewer energy levels. And the answer is, oxygen has fewer energy levels. That's the beauty of examining the pattern or trend of atomic radius on a vertical descent. Energy levels is the easiest way to distinguish atoms. So just to make myself clear, if we check the periodic table, oxygen is in period 2, while selenium is in period 4. Therefore, oxygen is smaller. Now let's talk about the atomic radius trend as you make a horizontal right on the periodic table or across the period. I don't like to say across the period anymore because students often get down the group and across the period confused. So I'm going to stick with making a horizontal right on the periodic table. So what happens? The atomic radius actually decreases or gets smaller as you move on a horizontal right on the periodic table. Why does this phenomenon happen? Well, it's because there's an increased nuclear charge. When you add protons to the nucleus, the protons actually pull the electrons in tighter. Yes, we know electrons repel each other, but the protons and their Coulombic attraction actually have a greater effect on the electrons than the electrons have on themselves. So even though there are more electrons, protons in the nucleus win the tug-of-war battle. So atoms on the right side of the periodic table tend to be smaller than the ones on the left. So now let's practice. Which of the two atoms below has a larger atomic radius? Is it calcium or bromine? I hope you chose calcium, but why is calcium larger than bromine? Is it because calcium has more energy levels or fewer energy levels? Is it because calcium has fewer protons or more protons? Since we're talking about the atomic radius trend as we make a horizontal right on the periodic table, we can't be talking about energy levels. These atoms must be in the same period. We must be working with the protons. Thus, the reason why calcium is larger is because it has fewer protons. It cannot hold on to its electrons as tightly as bromine. Let's try one more practice problem about the atomic radius as we make a horizontal right on the periodic table. Which of these two atoms has a smaller atomic radius? Is it going to be carbon or neon? I hope you chose neon, but the question is, why is neon smaller? Is it because neon has more electron shielding or less electron shielding? Is it because neon has a lower nuclear charge or a higher nuclear charge than carbon? Again, we're talking about the atomic radius trend as we make a horizontal right on the periodic table. So we cannot talk about the electrons and their shielding or their energy levels. It doesn't make any sense. These two atoms are on the same period, so they have the same number of energy levels. Therefore, the reason why neon must be smaller is because it has a higher nuclear charge, it has more protons, and it can hold on to its electrons much more tightly than carbon ever will be able to do so. Alright, so let's recap the atomic radius trend. As we move from the top of the periodic table to the bottom, the atomic radius increases due to the energy levels. As we move from the left side to the right side of the periodic table, making a horizontal right, the atomic radius tends to decrease. Notice that there might be some exceptions to this trend, but for the most part, this is a pretty reliable way to predict which atoms are smaller or larger when you compare their positions on the periodic table. I hope this chemistry lesson was a refreshing spring rain to you. If it was, please share your thoughts in the comments below. Let's continue to explore the fascinating world of chemistry and share the excitement of scientific discovery. To receive more chemistry lessons and engaging content, consider subscribing to this channel. Together, let's deepen our understanding of chemistry and witness the wonders it holds. Remember, knowledge is meant to be shared, so feel free to share your chemistry questions or topics you'd like to learn more about in the comments. Let's unite in our pursuit of knowledge, discovery, and understanding. May your passion for learning continue to grow, and may you experience the joy of uncovering the mysteries of chemistry. Happy experimenting!